Hi there, I'm Mr. Brash, this over here is Mr. Squirrel, and welcome to another one of my math videos. Today I'm going to be talking about solving quadratic equations. So we're going to be given something like this right here. So how do we solve something like this question? When does 2 times x minus 7 all squared equal the number 162? And you're probably like, I'm sorry, what? So I've got a little visualization of it over here. So we're just going to take a peek here at this graph. So this graph, this kind of bluish parabola right here, is the graph that I was talking about right here of the 2 times yada yada yada. So that's if we had y equals that. That's the blue graph. The sort of orangey yellow line is the value 162. So as we go across, right across this line, that would be the y value of 162. And I know that the graph isn't exactly wonderful, but hey, it is what it is. So here's my y-axis, here is my x-axis down here. So this would be my vertex, and we're trying to figure out that value. So we're not going to do it from the graph. That'd be very difficult to eyeball and figure out, especially if it's a decimal value. So here's what we're going to do. We're going to build up to that answer. We're not going to get that answer right away. We're going to build up to it. So let's start here. Let's start by solving each of the following. So if I have x squared equals 9, my job is to figure out what x is. Now there's a couple of different ways you can think about it. You can think about it as x times another x gave me a number times a number that equaled 9, and I got to figure out what those two numbers are. And so your brain might automatically know that the answer was 3 times 3 to give you 9. But there's actually a different answer as well, because negative 3 times negative 3 can also equal 9. So the realistic way of doing this would be to square root both sides. So we would take the square root of x squared and we would take the square root of 9, and because the number 9 can come from either the positive 3 times 3 or the negative 3 times negative 3, we actually have two different answers when we do that square root. So sure, I can cancel out the squaring of x with my square root here, and that gives me x equals positive or negative 3. Very important process, very important for you to understand why that is and how that is. Because this is a math video, I do encourage you to pause the video at any moment, especially when you see questions like this, and try them on your own before I go through them. Speed the video up, skip back and forth between different parts of it, watch what I say again, and of course, check out some other videos like the ones from Khan Academy and stuff like that to compare and contrast how I'm teaching this. All right, next up, we've got one slightly different. So in this case, we have a constant that's been tacked on with our x squared. So if you're any good at algebra, you would know that we need to first subtract the 4 on both sides, and then we'll get our x squared all by itself. X squared is 64. We would take the square root of both sides. Square root of x squared is just x, but the square root of 64 is 8. But it's not just 8, it's positive or negative 8. So we would say that x is 8 and, or, depending on how you want to look at it, and or, probably be more like and, x is negative 8. On to letter C, slightly different again. I've got a constant, but I also have a coefficient on my x squared. So we're going to add 75 to both sides of this equation, and we'll end up with 3x squared equals 75. We'll divide now. So I'll divide both sides by the 3 to get it away from the x squared. So these two 3's are going to cancel, and I'll divide 75 by 3 on the right. So I've got x squared equals 25. We are now going to change to make the square root here of x squared. That's going to give me x equals positive or negative 5. And so we would say x is equal to negative 5 and x is equal to 5. Now, the order in which you say these, they don't really matter. All right, I did the positive 8 first here and I did the negative 5 here. All right, moving on here, let's try that original question. So the original question with the graph that I showed you, we're not going to use the graph. What is the solution to that original question? And a little kind of fun pun for myself here. We're going to get to the root of the problem. But what we're asked to do here is figure out what x is, essentially. And this is very similar to the previous questions I just did, but slightly more complicated. So we've got a constant on the right-hand side. We've got a coefficient outside the bracket on the left-hand side. So we know from the algebra skills we have, we're going to divide the 2 on both sides here so that I can cancel the 2 on the outside coefficient. 162 divides by 2 quite nicely, very convenient. That's 81. Now what I have is I have an x minus 7 squared. I would love to add 7 to both sides, but I can't do that yet. I've got a squared on the outside of that bracket. So as you saw in my previous examples, I'm going to square root both sides. That's going to cancel out my square on the bracket. And the square root of 81 should be known to us. It is both a positive 9 and a negative 9. So I know that x minus 7, okay, after taking the square root, this is just x minus 7, is going to be equal to either positive or negative 9. So what does that mean? Well, that means we have two potential solutions. We have x minus 7 is equal to positive 9, and we also have x minus 7 is equal to negative 9. And so that's going to give us the two different answers. So let's add 7 on both sides. So I'll get 16. And over here I'll add 7 on both sides, and I'll get negative 2. I should get an answer of 162 when I plug 16 into this equation, or I plug negative 2 into this equation. Let's take a look at the original graph. So my scale here is jumping by 2's, and one of my answers was negative 2. So this would be negative 2 right here. And by doing the algebra, I figured out that I would be at 162 at an x value of negative 2. And that checks out on the graph. On the positive side, it said 16. So this would be 2, 4, 6, 8, 10, 12, 14, 16 right here. And sure enough, if I go up here, I can see that that is exactly when the graph is at a height of 162. We're lucky that these are whole numbers. Obviously, it was tailored that way. You wouldn't want to use the graph if there were decimal numbers like 16.1, let's say. And so if I wanted to, finalize this statement in a nice clean fashion, I might say, therefore, the roots at 162 are 16 and negative 2, or something along those lines. Depending on who your teacher is, depending on how you've been taught your math, you might state that in a different way. Now, before we continue, I'd like to consider this x minus 7 squared piece of this, because there's a really important item to understand, and it's the fact that x minus 7 squared, if that was sort of a scenario on its own, and I was just to say, okay, x minus 7 squared equals 81, we have to understand that x minus 7 squared could be written as x minus 7 times x minus 7, and that is equal to 81. So I'm going to tackle that with a couple different questions here. We're not going to do that exact example. We're going to take a look at these. So I've got here an x times x plus 6 equals 0, and because of our training, we're desperate to write by expanding. We're desperate to expand this x into this bracket, but I implore you, don't do that. You're going to waste your time. What this is saying that x times another piece gave us 0. And the one thing that we really know about multiplication is that anything that equals 0, when you're multiplying, came from 0. And I'll explain this a little bit further, but if I had 3 times x and that gave you 0, what do you know about x? Well, you know x is 0. If I had y times 4 and that is equal to 0, what do you know about y? Well, y has to be 0 in order to make this multiplication equal to 0. So I've got two items here. Of course, I could, if I wanted to, I could divide both sides by x. So sure, let's divide both sides by x so that it cancels on the left-hand side. And when I do that, I'm left with x plus 6 equals 0, because 0 divided by x, still 0. So I end up with x plus 6 equals 0. If I bring the 6 over, I get x equals negative 6. But that's if I divided by x on both sides, right? So what if I didn't divide by x on both sides? Let me quickly erase that. What if instead I actually divided by the x plus 6 on both sides? Not something you'd be used to, not something you would typically do, but the x plus 6's would cancel. 0 divided by anything is still 0, and I'm left with x. So I'd be left with x equals 0. So that means that either the x was the 0 to make this multiplication equal 0, or the x plus 6 was equal to 0 to make this multiplication equal to 0. A little bit confusing, a little bit complicated, but it all comes from that multiplication fact of how do you get 0 when you're multiplying. So I'm just going to break this up into its two pieces. So I have x could be 0, and that's as far as it goes, and I have x plus 6 could be 0, and that's as far as that goes. So these are the two answers that make this true. You could check by just plugging them back in individually. Over here, I've got a factored form, something you would have seen from factoring trinomials if you know how to factor trinomials. And again, I'm really interested in expanding it out. My brain says multiply this all out, but I'm telling you, don't do it, because we have a simple multiplication. This is like saying I have, let's use two different letters. Let's use W, and on the left here I've got W, and on the right Z. Let's just put Z here. So W times Z is equal to 0. That's essentially what this statement is saying. And as I said before, if I had 3 times something is 0, you know that something is 0. If I had 4 times something is 0, you know that that something is 0. So I have the possibility that W is 0 or the Z is 0. And so my W is the x minus 7. So I think the x minus 7 might be 0. Or, and I can even write that, I can use the word or, x plus 2 equals 0. X plus 2 is the thing that is 0 that makes this multiplication equal to 0. And now I can solve these individually. These are just simple algebra statements. X is 7 or x is negative 2. And I can individually plug those in to figure it out. If I put 7 into this bracket, so if I go ahead and I put a 7 right here in this x, and I put another 7 right here in this x, 7 take away 7 is 0. This bracket became 0. So when I multiply it out, everything becomes 0, and it just totally works out. Or I can put negative 2 in. And the reason I can do that is because if I put negative 2 in this bracket right here, negative 2 plus 2 is 0. And so 0 times this stuff would be 0. And so everything just got negated out. And I've said 0 way too many times on this particular page. So we're going to do one last example to do with this, but I want you to be careful with this particular question because it's a little tricky. We would really love to just divide both sides by 10 here to get the 10 off. And if we go ahead and we do that, I'll get x squared equals negative 4x. And then on the same sort of vein, I would really like to divide both sides by x. It's really tempting to do that, isn't it? So I'm going to divide by x and I'll divide by x. So they cancel here. And we know that if we have the same base and we're dividing, we subtract our exponents. And so I end up with x equals negative 4. Nice and simple. Clean. It's just one answer and away we go. But what we've done is we've accidentally gotten rid of one of our solutions. So I'm just going to show a different way to do this. Let's get everything to one side. And that's your first step that you should always do. So first step, I want to make the equation equal to 0. Make the equation equal 0. And that, my friends, is one reason why we are going to be solving for the zeros. If you know anything about parabolas, they have zeros. So I'm going to bring that 40 over to the left-hand side by adding 40x on both sides, and I now have an equation equal to 0. And I'm going to focus on the left-hand side of this equation. I'm going to look for something that's in common. I'm going to look if I can factor. I'm going to look for all sorts of different ways to make this a little bit easier for myself. I can see that I have a 10 and an x in common in both of these items. So I'm going to factor out 10x. So I'm just doing common factoring right now. This is just GCF. And what I'm left with is two different items. So I'm just going to package this 10x in its own bracket as well. Two different items that are equal to 0. Now, how can we figure out what x should be to make this statement true? Well, I'm going to propose a question. If I had two numbers, we'll call them a and b. So if I had a times b, and the answer to a times b was 0, we need to ask ourselves, what do we know about a and what do we know about b? Well, it might be that the a, one of these two numbers has to be 0. So it could be that it is 0 times the letter b, which is what gave me 0. But of course, it could also be that the letter b was 0, and in fact, it was a times 0, which gave me an answer of 0. Well, I have a multiplication in my yellow section here as well. I have a multiplication that says that the 10x might have been 0, or the x plus 4 might have been 0 in order to make this multiplication true. And I can solve individually for these two different statements. This is just a linear scenario here and a linear scenario here. I can divide both sides by 10, which is super easy because 0 divided by 10 is just 0. And then I can subtract both sides with the 4, and I get x equals negative 4. And so now I actually have two solutions. I have the x equals negative 4 that I had when I did it this way, but I end up with another solution that x is equal to 0. So there's two different ways that this original equation could be true. And is there, maybe a way that I can check that? Absolutely. I can plug these values in. What we want to do is we want to make the equation equal to 0 and see if we can factor. So we're going to try common factoring. Try common factoring. It's really crucial. And so for now, that's where I'm going to leave you. So we're learning how to solve parabolas, solve quadratic scenarios or equations, but doing it algebraically, not the graph. We're going to start by simple algebraic manipulation, typically with a square root, and the understanding that a square root gives us two possible answers, a positive and a negative. And that's the real easy way to do it. But then also sometimes it gets a little bit more complicated where it's a longer or larger algebraic statement, something that might look like vertex form if you happen to know what vertex form is. And then sometimes we need to use common factoring to get a final solution. Now I know this video went really quickly. That was on purpose, trying to get through these a little bit fast. Please leave a comment for me, any sort of constructive criticism. If you liked the video, give me a little like. Look for subsequent videos. I'm going to be showing you how to solve more complicated quadratic scenarios later on. And of course, if you're so inclined and want to subscribe to my channel, hey, I'd appreciate that. Go for it. That's it for now. Keep practicing math.